Okay, another dot problem. We typically like these problems here. It helps me to write down the coordinates of those points. You don't have to do that, but you're gonna make the little slope field, make the little hash marks here. So the reason I wrote these down all together, because if the x value is 0, it was gonna be 0 times a number. Those slopes are all gonna be equal to 0. So if those slopes are 0, then we put the horizontal hash mark there. And then at the other points, all you're doing is taking these numbers, plug them in for x and y, because this is your derivative is slope. This will give you the slope of each point. So if I plug the 1 in for the x, I plug the 0 in for the y, you're going to get a 1 times -1, which will give you a -1. So just do basic arithmetic, no calculator on this one, do basic arithmetic, get all your slopes, be careful with that, and then it's all relative. So if the slope is 1, make it, kind of normal, and if the slope goes up to 2, then you make that steeper. So as long as this one has a slope steep than that one, it's kind of nice. We only got a couple to worry about. You just do that at each one. Then you got a negative slope of -1, and then yeah, that's it, -1, -1. So they'll be about the same steepest levels. And I got 1 slopes there, then 2 slopes there. So there you go. And then it tells you 12 points. So make sure you got all 12 of them. So just do some arithmetic. Be careful with that. Part B was just, I don't know, I really like part C. That'll be in our wheelhouse there. We'll be really, really strong at the differential equations of part C. But part B just says, looking at the slope field, describe all the points in the plane where the slopes are positive. So as I look up here, the slopes are positive at 1, 2, 3, 4, these 4 dots only. Okay, and it says describe them. So I just noticed that, hey, the y's were bigger than 1, but then I couldn't include those ones. So I had to take off where it said x is equal to 0. So I just kind of jotted that down. Y is greater than 1, x is not equal to 0. There's no calculus involved with that. You're just kind of looking at that thing and kind of writing that answer down right there. Now, where most of our points at, this is our money ball right here, where most of our points are at, are on this letter C, okay? I believe on the 9-point problem, this is typically worth maybe 6 points right here. But when you see the phrase, find the particular solution to the differential equation given an initial condition, if you got stuck, I mean, that's in your blue pack where it's talking about solving differential equations, find a particular solution to the differential equations. And a lot of times it'll say use separation of variables. It'll say separate the variables, right? First separate the variables if you need to. But this is when you're going to get the y's with the dy, x's with the dx. You're going to integrate both sides. You're going to remember your plus c. You're going to use the initial condition to plug it in to figure out what that c value is. And then you're going to plug that back in and you're going to solve that for the y. And so I started with that, multiplied both sides by the dx, and then here's my first thing. And notice I got that y's with the dx. You have to get rid of that. Legal algebra, right? This is all multiply. So if I divide both sides by the y minus 1, I get 1 over y minus 1 dy equals x squared dx. Got an easy integral there, easy integral there. Remember the plus c, put the plus c on the side the x's are on. Use that point, plug in the 3 for the y, plug in the 0 for the x. You get your c as the ln of 2. Then you can plug that back in. And typically, we'll talk about the point values at the end of this thing, but once you find that constant of integration, what I would like you to do, we have to do these a lot, it seems like, with the ln's in the problem. And I used to solve these a few different ways. I think we'll all be happy just to get some consistency with these. And so whenever I have ln's on different sides, I group my ln's together. I move all my ln's to one side, and then I use my pre-calc property to merge those together. And then I use the main definition of a log. Remember, if you have log base b of a equals c, you can go b to the c equals a. So then you can go this to this equals a. You go e to the x squared over 3 equals the y minus 1 over 2. And then I need to solve for y because it says get y equals. That's why we need to solve for y on these things here. So I'm going to multiply both sides by the 2 first, then just add 1 to both sides, and then you're done. Now, just point value wise, if this is a 6-point problem, they'll probably give you 1 point if you separate your variables. So like if you get to this guy right here, you get 1 point. And then they give you 2 additional points if you just integrate properly. So you integrate it, you got 3 out of the 6. And they say if you don't find the c value, then the max you're gonna get is the 3 out of the 6. So you have to remember your plus c. And then once you find it, that's typically worth 2 additional points. And so that's going to be 5 out of the 6 points right there. And then the solving part, if you are having any time issues, that's typically worth 1 more point at the end right there. But also, this is going to be a strength of ours, so you might as well just spend some time on that. Make sure you know that thing, and just get all 100% of your points on that thing as much as possible there. But yeah, we like those dot problems. Vote.